Welcome to this lesson from our MLOps coding course. Today, we are diving deep into a topic that's just, well, absolutely critical for leveling up your skills for production, Python typing. In this explainer, we're going to see how this one discipline can take your data science projects from being fragile little scripts and turn them into robust, production-ready MLOps systems.
So here's our game plan. We'll kick things off by understanding the core problem that typing actually solves. Then we'll look at the tools Python gives us right out of the box. From there, we'll get into some game-changing libraries like Pandera and Pydantic. And finally, we'll see how to automate all of this across your entire project.
All right, let's start with a pain point. As data scientists, we're masters of exploration. But the moment our code has to run reliably, day in and day out in a production pipeline, a whole new set of challenges pops up. I mean, if you've ever had a model that works perfectly on your laptop with that nice, clean CSV file, but then it just dies in production because a column suddenly has a string in it instead of a number, you know exactly what this feels like. It's that fragile house of cards that can come crashing down at the worst possible time. Adopting typing isn't just about adding extra syntax. It's a strategic investment. It gives you a safety net that catches errors before your code even tries to run. Your code basically starts documenting itself. Your IDE gets way smarter, giving you better auto-completion. And collaboration, it gets so much easier because everyone on the team understands the data contracts you've set up, which is a huge concept in MLOps.
So how do we actually do this? Well, thankfully, modern Python has really evolved to give us some powerful tools for typing, and it does it without taking away that flexibility we all love about the language.
Now, this is really interesting. To get what's going on, you have to see where Python fits in. It's always been a dynamically typed language, right? Checks happen on the fly. But since version 3.5, it's embraced what we call gradual typing, which lets us add optional static checks. It really gives us the best of both worlds, the safety of static typing right where we need it, but the flexibility of dynamic typing everywhere else.
Okay, here's the crucial point. You have to get this. Adding type hints to your Python code doesn't actually change how it runs. The interpreter itself just kind of ignores them. The real magic happens when we use external tools, a process called static analysis, to check these hints and warn us about problems before the code ever gets near production. And this just illustrates the payoff perfectly. The before version is a total mystery box. What is name supposed to be? Does it return anything? Who knows? But the after version, it's crystal clear. It expects a string for name and it returns none, which means it returns nothing. Your code is now its own documentation. Okay, for any data scientist, the single most important data structure we deal with is the data frame, right? It is the lifeblood of our work. So let's look at a specialized tool that's designed to make our data frames safer and way more predictable. Think of Pandera as a blueprint for your data, or better yet, like a really strict bouncer at the door of your function. Before any data frame is allowed into your code to be processed, it has to match the validation schema you defined. This just wipes out a huge category of data quality bugs right at the source. And the process is really straightforward. First, you define a class that's going to act as your schema. Inside that class, you declare each column you expect, like user ID has to be an integer. Then you can get even more specific with validators, like saying a rating column has to be between 1 and 5. Finally, you apply this thing called a decorator, that little @para check input thing, to your function. And just like that, it automatically runs the validation for you every single time.
So data frames are handled. But our ML projects are full of other data structures, right? Things like configuration objects, API requests, all that stuff. For those, the absolute gold standard is Pydantic.
Pydantic is like a data class on steroids. It enforces your types at runtime, so it validates data the second you try to create an object. And because its core is written in Rust, it is incredibly fast, which is perfect for production APIs. Oh, and speaking of APIs, this is huge for MLOps. It can automatically generate the JSON schemas you need to define and document your model's API. It makes integration so much easier.
And you'll notice the pattern here is a lot like Pandera. You define a class as your blueprint, you declare your fields like learning rate, float, or model name, string, but the real magic happens when you actually create an instance of this class.
You can just throw a messy dictionary at it that you loaded from some YAML config file, and Pydantic won't just validate it, it'll automatically coerce the types for you, like turning the string 0.01 into a float. You get a clean, reliable settings object every single time. It's amazing.
Okay, so we've learned how to write the type hints and use libraries that enforce them. But the real power, the secret sauce, is automating the whole process. We need a tool that can act as our continuous safety net.
And for that, we turn to MyPy. This is the industry standard static type checker for Python. You run it on your code, and it acts like a super strict proofreader. It just scans all your type hints, and it flags any place where the types don't line up. It is your first line of defense against all those type-related bugs. Now, while MyPy is the classic choice, and it has a huge ecosystem, it's good to know about the alternatives. PyWrite from Microsoft is crazy fast. It's actually what powers the type checking inside VS Code. And Pyre from Meta is also built for pure speed on massive code bases. But for most projects, MyPy is a fantastic place to start.
Now to make MyPy really effective, you need a shared configuration file. By putting these rules right in your pyproject.toml file, you make sure the whole team is playing by the same rules. For example, disallow untyped defs equals true. That is a powerful setting. It means any new function a teammate adds must have type hints. It just systematically raises the quality of your code over time and stops untyped code from creeping back in.
Okay, but let's be real. We all know that sometimes, especially when you're wrestling with older libraries, you just need a way out. MyPy gives you a simple escape hatch. You just add the comment #typeignore to a line, and it tells the checker, hey, look the other way on this one. Just use it sparingly.
So let's bring this all together. Be pragmatic. Use the 80-20 rule. Focus your energy on typing your function signatures and your data models first. That's where you get the most bang for your buck. But the most critical takeaway for MLOps is to automate it. Integrate MyPy right into your CI/CD pipeline as a required check. That means broken or incorrectly typed code gets blocked before it can ever be merged. That is how you protect your production systems. And that brings us to the end. As you keep going on this journey from data science to machine learning engineering, I want you to always ask yourself this question. We spend so much time validating our model's accuracy, but in a real-world MLOps system, the code itself can be the weakest link. Validated, robust, reliable code is just as critical as an accurate model, and typing is your #1 tool for building that solid foundation.